welcome back, guys. This is the next part of the lesson on gases. So we were talking about pressure and the relationship between the different types of pressure. I also stated that the only reason why that's important is because you may need to convert between one and the other type of pressure. So I have a few conversion factors that will be helpful in the problem that you see below. How do we convert from ATM to torr and ATM to PSI? So the first thing that I need to know is there a direct conversion factor between ATM and torr? And I do see one that has 1 ATM is equal to 760 torr. And then is there a conversion factor between ATM and PSI? And I see another one right here, 1 ATM for 14.7 PSI. If there wasn't one directly, or at least listed, I could have also gone from torr, once I calculated ATM to torr, to PSI using this conversion factor. Whichever works for you, whichever one you like to do is fine by me. Okay, so I'm going to convert my PSI or my ATM to torr first, and I'm going to start with that 1.20 ATM, and I'm going to use this conversion factor here. Because I know that I need to get rid of my ATM, instead of setting it up the way that it's listed, I flip it so that those ATMs can cancel. I'm left with torr. I do the math, 760 times 1.20, and I get 912 torr. So 1.2 ATM is about 912 torr. My answer started in 3 sig figs, and my final answer, or my problem started in 3 sig figs, so my final answer has to also be in 3 sig figs. All right. The second part of that is to go from ATM to PSI, and I'm using this conversion factor. And I'm going to set it up very similarly, but I'm using the 14.7 PSI instead. My ATMs cancel out, and I'm left with PSI. And so from a math standpoint, 14.7 times the 1.2 gives me 17.6 PSI. Hopefully that wasn't too fast. If you have questions, please do not hesitate to reach out like you all have been doing, and I'll be more than happy to answer those questions, okay? You can replay this as many times as you need, and like I said, ask questions. So this next slide here has the chart that you guys were supposed to try on your own. We're going between different types of pressures from one to the next, using that information that we provided on the previous example, or even on the previous slide, okay? If you have it already filled out and you wanted to just check, you can do so. If you haven't, and you wanted to take a few moments to see if you can figure out how you got that, you can do that. You can pause the video here, or you can just write them down and hope for the best. It's entirely up to you. I suggest that you learn how to do it, though. All right, so the next thing I want to talk about is standard conditions. A lot of times you will see a problem that says this gas is at STP, or this, you started here and it ends up at STP. And you may not know what STP means. Well, STP is the standard temperature and pressure. Now that sounds wonderful, but what does that really mean? I don't know what the standard temperature is. I don't know what the standard pressure is. Well, the standard temperature, let's handle that first. That's a lot easier to deal with. The temperature in this chapter, every single temperature must be in Kelvin. So the standard pressure, standard temperature will every single time be 273 Kelvin, which is about 0 degrees Celsius. All right, so that part of it's going to be easy. So if I have a question that says, we started at this temperature and we ended at STP, but you don't know what that is, or you may think you don't know, because that's what I usually get. Just remember, STP, standard temperature, is always going to be 273. Now, standard pressure is a little bit different. Depending on the circumstance, your pressure can be either in torr, in kilopascal, in ATM, and so many different things. The slide that we talked about, those different types of pressure, that's what we're talking about here, okay? So the key thing here is to determine which one you need. Look at the starting point. If you're starting in torr, chances are your standard pressure is going to be 760 torr, okay? So just make sure that the question that you're answering and the final temperature, or excuse me, the final pressure, they match up. If you're not given ATM or pressure, I suggest using ATM as your choice, okay? So if you're trying to figure out what the pressure would be in the end, shoot for ATM, because it's a lot easier to remember one than, let's say, 14.7 or 760 or what have you. But that's just my suggestion. All right, here's the first of the 5 gas laws that we're going to talk about in this chapter, Boyle's Law. Now, you may be familiar with Boyle's Law. You probably talked about that last year in physical science. And Boyle's Law, Boyle, he was actually the first guy to notice an effect with pressure and volume and to see their interaction. What he noticed was that as the volume was increasing, or the volume and the pressure were actually inversely proportional to one another. And we're saying that the temperature is being held constant because it's not a factor when we're talking about Boyle's. He was only focusing on pressure and volume. Now, when we say something is inversely proportional, that means that as I'm increasing one part of it, the other one is going to decrease. If I increase the pressure, chances are the volume is going to be decreasing. And if I increase the volume, then the pressure is going to be decreasing. So that's basically what we mean when we say they're inversely proportional. One's going up, the other one is going down, okay? Now, the formula for Boyle's Law is P1V1 is equal to P2V2. In this case, the P1 is my initial pressure. My V1 is the initial volume, and you guessed it, P2 is your final pressure, and V2 is your final volume. Now, as far as the units, they can come in any array. Pressure is usually going to be in like a Pascal or PSI or something like that, whereas volume may be milliliters, liters, cubic centimeters, something like that, okay? So let's look at an example problem. We have a gas that has 450 mils, or that it has a volume of 450 mils. It is under a pressure of 1.02 atmosphere. The volume will occupy, or what will the volume be if you increase that pressure to 850 torr? All right, and so because I know I'm doing Boyle's Law, that's usually my starting point. Which equation do I need? Well, Boyle's Law, that's the only one that I've shown you so far, so that kind of makes sense. So P1V1, so now I have to identify my P1s and my V1s and all that kind of stuff. So my initial pressure is taken from right here, which is 1.02 atmosphere. But I have a problem because I'm looking at it, and this is atmosphere, and this is torr. One or the other has to be converted. Whether I convert ATMs to torr or torr to ATM, I must convert one to the other. So going back a few slides where I showed you how to convert between pressure, it's going to come in handy here. I decided to convert my ATM to torr, so that's going to be 780 torr. And if you don't remember how I did that or how to do that, you can go back to see that conversion, the relationship between ATM and torr, to see how to set that up, okay? And again, you can always ask questions. My initial volume is taken from right here, 450 milliliters of that gas. My final pressure is 850 torr, and again, because I've converted that to torr, I'm good to go. And then my final volume, that's the thing that I don't know. That's the thing that I have to figure out. Now, I like to rearrange my equations and then plug in my numbers. If you like to plug in your numbers or put your numbers into the equation and then rearrange it, that is entirely up to you, whatever works best for you. But for me, I went ahead and rearranged my equation first, all right? Now, I know that for my V2, I divided both sides by P2, and so that's how I arrived at P1V1 over P2, okay? And then I plug in my numbers. Now, one of the things that I do encourage is for you to use your units. So my initial pressure, 780 torr, times my initial volume, 450 milliliters, divided by my final pressure, which is 850 torr. My torr units are going to cancel out, and I'm left with milliliters, which is a good thing because I need my unit my final answer to be in milliliters or a unit of volume. So when I do that math, I get 412.9. But when I look at my original problem, this number has 2 significant digits. This one also has 2 significant digits, but this one has 3. Your final answer should be to the least precise in the original problem. And in this case, I've rounded to 410 milliliters. Okay? Got to remember your sig figs here. All right, these are some practice problems, Boyle's Law. That should go on the left side of your notebook. If you haven't already done so, please do so. I will be checking that in the next notebook check, whenever that may be. But what I will allow you to do is to go online. There is a quote-unquote quiz. It's not a quiz grade, so don't be alarmed. The 4 problems are up there. Once you've done it on the left side, you can answer the problems and put them in just to kind of see how you did, okay? All right. Charles's Law is the second one. Again, this may be familiar to you. You probably learned that last year. Charles's Law, however, looks at the temperature and the volume and the relationship between the two. So while we were looking at the pressure and the volume in the previous example, temperature wasn't a factor. Now temperature is. The thing that you do need to know though now is pressure is being held constant. So we don't need to factor that in. Even if the problem includes pressure, if it's being held constant, don't worry about it. The pressure and the volume are directly proportional, not indirectly or inversely proportional. That means if I increase one thing, the other thing is also going to increase. If I increase my temperature, my volume is going to go up. If I decrease the temperature, the volume is going to go down. All right? And so that's kind of the relationship. So it's a lot different than Boyle's Law. Okay? Now, this equation, I think, is a lot easier. It's V1 over T1 is equal to V2 over T2. So, of course, my V1 is initial volume. My T1 is initial temperature. Notice I have a K. That just means that it's in Kelvin. You must put your unit, your temperature in Kelvin. All right, and I'll talk about that in just a moment. Your final volume, V2, and your final temperature, again, in Kelvin. So here we have an example problem. And the way that I like to look at this is that it's kind of like cross multiplying. I think that most of you guys know how to cross multiply. It comes naturally to you. And you can treat this problem the same exact way. So we have a sample of gas that's about 430 mils of volume, and its temperature is 25 degrees Celsius. What is the final volume if you have STP? Now, or its standard temperature rather. So the thing that you need to identify are the variables, right? I have my initial volume, 430 mils, my initial temperature, 250 degrees Celsius, but I also told you that it has to be in Kelvin. So we have to add 273 to the 25 degrees Celsius, and I thought I had it up here, but I think that's 298, all right? And then my final volume is the thing that I'm looking for, and then, of course, my final temperature. Remember I told you about STP, standard temperature, 273 there. I'm sorry that keeps blocking you guys, but it's 273 for standard temperature, okay? So when I plug in my numbers, it looks just like this. And so this is kind of like the X in math class that you're used to. And so you cross multiply, and when we do so, I get this number here, 117,390 mils, okay? And notice I kept the units because that's going to help me in the end. It's equal to the 298K V2. Again, this is like X. So if you wanted to make that X, you can certainly do so. In order for me to get V2 by itself or X by itself, I divide both sides by the 298. And my units of Kelvin cancels out here. So I'm left with milliliters, which is great. It's wonderful. Now, do you have to write this step out? No. This is what I need when you're showing me work right here. You don't have to show me this part, this, and then your final answer. I plug it into my calculators, my calculator, 117,390 divided by 298. I get 390. It's my final answer. All right. I'm going to run out of time, but there are some practice problems. Same thing, go online, do the problems. Good luck.